Hello, this is Lazarus at Telecom Tech, where telecom and networking technologies are simply explained. In this video, we'll be simply explaining how to subnet IPv4 networks. Now, this is the third video in a series on subnetting. In part 2, we tried to perform subnetting using variable length subnet masking, or VLSM, but we deliberately attempted to do so without putting the subnets in order of decreasing size. We saw how and why such an approach would fail. In this video, we'll be subnetting the same series of network segments, but we'll perform it correctly in order of decreasing size, ultimately successfully subnetting the networks. Before we begin, please take a moment to subscribe to my channel and to like this video if you find it useful. Now, when you use VLSM, you must subnet the networks in decreasing size. As we saw in part 2, if you don't do this, subnetting will fail. Let's correct the error we made in the previous video and perform our subnetting for the same enterprise network. So the address space we are given is 10.10.20.128/25. From this address space, we are asked to create 3 subnets of various sizes for an enterprise network. These subnets will have an expected number of hosts as shown here. One subnet will have 55 hosts, the other 27, and the third 4 hosts. Now let's take a look at our address space once again, 10.10.20.128/25. But let's examine it with the full subnet mask written out. That subnet mask is 255.255.255.128. Here we see it represented again, but with the last 2 octets in binary. We can see that with this subnet mask, we reserve 25 bits for the network address, and it's the last 7 bits that are defined as the host address. How large is this address space? Well, 2 to the power of 7 host bits is 128. Now, previously, we put these subnets in this order, where the second subnet is larger than the first. This is the error we made last time, but we won't make that mistake again. Let's put them in the correct order this time. Next, based on the required number of hosts per subnet, we must choose a subnet size. Remember, the sizes of our subnets are always 2 to the power of x, where x is the number of host bits. Now, I've already gone in and chosen the most appropriate subnet size for each of these subnets. Now, that number in red is actually the number of host bits that we're going to use. So automatically, you know the number of network bits. And thus, you know the subnet mask that we will be using for each of these subnets. Now, notice that for subnet number 3, where we need 4 hosts, we can't use a subnet mask of 2 host bits because that would give us 4 addresses. But remember, the network and broadcast addresses are reserved, which are the first and last addresses in the subnet. So we would only have 2 usable hosts. So for 4 hosts, we must use the next largest subnet size, which requires 3 host bits, giving us a size of 8 addresses, of which 6 are usable host addresses. So these are the number of host bits that we will use for these subnets. And these are the sizes of the subnets that will result. So let's start subnetting our address space. Let's take a look at the details of subnet number 1. We have 55 hosts, we have 6 host bits, which gives us a range of 64 addresses. With 6 host bits, that means that our subnet mask in binary is composed of 26 ones and 6 zeros, like so. In dotted decimal format, that comes to 255.255.255.192. Now, to start subnetting, we take our initial address space of 10.10.20.128 and we'll write it out with the last 2 octets in binary. Then we put in our subnet mask for the first subnet, which is 255.255.255.192. And we'll also represent this with the last 2 octets in binary, like so. We now draw a line at the point where the subnet mask tells us that the host and network portions are split. Our subnet mask says that the first 26 bits are the network portion and the last 6 are the host portion. Next, we start by writing out the network address. Remember, this is the address that has all host bits set to 0. Next, we write out the first host address. This is simply the network host address plus 1. And now it would make sense to look at the last host address, but that's not always easy. It's always easier to determine the broadcast address. Remember, the broadcast address has all the host bits set to 1, and here is what it looks like. Finally, we can now look at our last host address. This is now easy to find because it's simply the broadcast address minus 1. So we have now found all the important addresses in this process for our first subnet. We have the network address, the first and last host addresses, and the broadcast address. The only thing that's left to do is to write them out in dotted decimal format. And here they are. Now, one thing to notice here is that the network address is actually the same as the original address space that we were given. However, it's actually not the same because our subnet mask is different. It's a smaller subnet mask, meaning that the resulting subnet is a subset of the original address space we were given. So that's the first subnet we created. Now let's go on to the next one. Here we see again the size of subnet number 2 is 27 hosts. For this subnet, we need to use a subnet mask that provides us with 32 hosts. That means that we need 5 host bits. Now looking at the subnet mask, we get 5 zeros at the end for the host portion, which translates to a subnet mask of 255.255.255.224. Now previously, for the network address of our previous subnet, we used the network address of the address space we were given. What network address are we going to start with here? Well, we always use the following rule. The network address of this subnet is the broadcast address of the previous subnet plus 1. So for our first subnet, we had a broadcast address of 10.10.20.191. Adding 1 to that, we get 10.10.20.192. So this is our network address for subnet number 2. Now, once again, we use our network address and our subnet mask, and we are representing the last 2 octets in binary. Then we draw a line separating the host portion from the network portion based on the subnet mask. Here we have our network address for subnet number 2. Now, in the previous video, this is where we had our problem. The line separating the network from the host portion was actually found here. And our network address had a 1 in this bit position. That's not allowed for a network address, so the whole premise of our subnet was violated. But here, because we chose the subnet sizes in decreasing order, the separation between the network and host portion, this line, progressively moves to the right, thus ensuring that all bits to the right of that separator for each subsequent subnet are all zeros, thus not violating the requirement for the network address. Well, let's go on. Next, we write out the first host address, and this is simply the network host address plus 1. And as we always do here, we go on to determine the broadcast address. Remember, the broadcast address has all the host bits set to 1, and here's what it looks like. Finally, we can now take a look at our last host address, which is easy to find because it's simply the broadcast address minus 1. So now we have found all the important addresses in this process for our second subnet. We have the network address, the first and last host addresses, and the broadcast address. The only thing that's left to do is to write them out in dotted decimal format, and here they are. So that's the second subnet we created. Now let's go on to our third and final subnet. Now the size of this subnet should accommodate 4 hosts. To do that, we need to use 3 host bits, which will give us 8 addresses. But remember, we only have 6 usable host addresses since the network and broadcast addresses are reserved. So looking at the subnet mask, we get 3 zeros at the end of the host portion, which translates to a subnet mask of 255.255.255.252. Now to get our network address, we take the broadcast address of the previous subnet and add 1. So we take 10.10.20.223, and we add 1 to that to get 10.10.20.224. And this is the network address for our subnet number 3. Now, once again, we use our network address and our subnet mask, and we represent the last 2 octets in binary. We draw that line separating the host portion from the network portion based on that subnet mask. And here we have our network address for subnet number 3. As you can see, our network address is a valid address since all of the bits in the host portion are set to 0. Next, we write out the first host address. This is simply the network host address plus 1. Then we go on to look at the broadcast address, which has all of the host bits set to 1. And finally, we take a look at the last host address, which is simply the broadcast address minus 1. So now we found all the important addresses in this process for our last subnet. We have the network address, the first and last host addresses, and the broadcast address. The only thing left to do, as always, is to write them out in dotted decimal format. So that's the third and final subnet. Now here is a table that summarizes the address spaces that we have allocated for all 3 subnets. As with all of these subnetting videos, I suggest you take my original subnetting requirements and attempt to perform the subnetting yourself. You can then follow along with the video step by step to see if you can get the same results. I hope you found this video useful, and if you have, please click that thumbs up button. If you'd like me to address other related topics, please feel free to let me know in the comments below. And please subscribe to get updates to newly published videos. I'm Lazarus at Telecom Tech. I hope this has been helpful for you, and I'd like to thank you for watching.